Looks like it's recording. I'm Doug Stillers. I'm from the United States. I'm from Seattle, Washington. And I've been working on mobile web performance for about the last 7 or 8 years. And right now I'm traveling with my family through Europe, and we were in Brasov, and so I contacted the hosts here and said, would you be interested in hosting a meetup? And they graciously said yes, and so that's why I'm here. And thank you guys all for coming to listen to me talk. And I apologize, I speak no Romanian, so I'm going to speak in English. So to start off, how many of you work in mobile, whether it's web or Android, iOS? Okay. A few. That's great. How many of you thought about like the speed of the websites you work on or the performance of the websites that you're working on? Awesome. Great. So that's what I'm going to focus on here a little bit, and we'll see if I can make... We're using a different computer because my computer would only show up in the upper left-hand corner of the screen, so it wasn't working. So we'll see how this works. All right. So I'm going to start off with this picture. And how many of you kind of get a pit in your stomach when you think about walking across this walkway on a cliff in the middle of the Alps? You're just kind of like, ugh. Walking out that's kind of scary. Well, so it turns out that Ericsson did this study about a year ago where they put sensors on people's heads to see how they responded to different stress levels. And it turns out that standing in line is moderately stressful, but standing on the edge of a cliff is actually pretty stressful. It gets a 0.8, so that's like an actual stress response that people find. But they found that actually experiencing a mobile delay is more stressful than that pit in your stomach you get when you think about looking over the edge of a cliff. And then we could talk about math later, but there's people really don't like mobile delays. It stresses them out. And so when people are visiting your website or your mobile app, you don't want them to start off feeling stressed. You want them to go in happy. So let's talk a little bit more about that. So how much do people hate delays? Google did a study, and this is ad click data. So, people clicking ads, 53% abandon the site after 3 seconds. So if it takes longer than 3 seconds, they're done. Another company did a study where they added half a second of delay, and their customers got more frustrated and less engaged. Walmart and Amazon found that for every 100 milliseconds, they lost 1% of their revenue. So, if your idea is to make money with your website or your mobile app, that's kind of important too. But the best stat of all, and it's kind of right in the crack right there, says that 4% of mobile users admit to throwing their cell phone when an app or a website is slow. So when you see people walking down the street with a cracked screen, it might be because they got so angry at the app that they were using that they threw it. I'd recommend a pillow, maybe your bed. Don't just throw it on the ground. My phone is cracked, so I can't really say anything either. But as I was preparing for this talk, I saw this tweet. And this study, he's looking at his website. Harry Roberts does a lot of performance stuff. And so he was looking at, these are the amount of time in seconds it takes the page to load, and the height here is how many people did it. And he finds, this is the pink line is the bounce rate, how many people leave at a certain amount of time. So you can see as it takes longer, more people bounce. And so obviously, the faster the page loads, the lower the bounce rate, the more people are actually on his site using it. And we'll come back to this graph in a little bit. So this is sort of makes it a complicated thing because your customers demand a rich, immersive experience that's also fast. And sometimes, rich and immersive doesn't necessarily mean, that means a lot of content, maybe videos, maybe images. That doesn't necessarily come with fast. So this is kind of a hard thing to work together. So let's talk through some of these things. And one of the problems is cellular networks are high latency. And so to establish a connection on 3G can take up to 2.5 seconds. And you may see that if you're on 3G, like you click a link on the browser and it feels like it takes a second before anything happens. That's your phone talking to the tower and establishing a connection before you even get to TCP IP, before you actually begin transmitting data. And you can see that there's long round trip times, 200 milliseconds, 100 milliseconds, compared to Wi-Fi, which are relatively fast. And because of these long times, what ends up happening, this is a picture from a tool from AT&T called Video Optimizer. And it records all the packets that come in and out of the device. And you can see this is modeling a cellular radio. And you don't want the cellular radio on your phone on all the time, because we're plugging in our phones everywhere we go anyway, because the battery's dying. When the radio's on all the time, that's just killing your battery. But what carriers have done is if packets have come in, they leave the radio on for a little bit in anticipation of more packets coming. And so you can see here the radio's on for another 10 or 15 seconds in anticipation of future packets. Nothing comes in, so the radio turns off. You can imagine, I've seen mobile apps that ping every 5 seconds, and it's not that the radio turns on for that ping and then turns off, and then the radio's off for 5 seconds. No, the radio just stays on the whole time. It's almost the same as watching a video, because the radio is just always on. So it's important to know that the cellular radio stays on after every connection. That leads to battery drain, which is another thing that everybody complains about with their cell phones, right? I know I do. Okay, so what we're going to do today is we're going to walk through, I'm going to see if I can just do this and stand over here. Look at some of the tools that I use to benchmark websites and benchmark mobile apps. Look at some of the best practices to speed up apps and websites. Learn from existing tests. So for the last 7 years, I have been talking to top applications to help them make their network traffic more efficient and run faster. And basically, we've talked to hundreds and hundreds of companies, and it's like 2% of apps have no need for improvement. Everybody needs room for improvement. So we see these issues in top applications. Everybody has these issues, so we're going to walk through some so that you can learn from them and see the results of those performance fixes. So we're going to talk through some of the tools that are out there. This tool I've worked on for many years is called Video Optimizer. It's from AT&T. It's free and open source. I'm going to put all these slides up online so you can look at them later and get the URLs. But it's free and open source, and I'll talk a little bit more about it. For the web, has any of you used Web Page Test before? It's another free open source tool. You can test on browsers all over the world. There are instances of this in servers and in locations all around the world, and it will rate the speed, how fast all of the different parts of the website load, so that you can see what the load time looks like. And in Virginia, they actually have mobile devices that you can test on with Chrome, Safari, Firefox, all of those different things. And then website speed test is another one to look at how images can affect the download of your web page. And these two are integrated with one another. I can show that to you in a little bit. So Video Optimizer is a tool I've been working on for many years. And what it does is it's running a network trace on your mobile phone. So it's collecting all of the packets that come in and out of your device. Then we look at them and analyze them to see if they can be optimized in any way. So you can see here, it's looking at a device. You can pick the device. So if you have a lot of devices plugged into your computer, you can pick which device. You can choose the collector type. You can choose the type of attenuation. And what that is slowing down the network speed. So if you're connected to Wi-Fi, you might be getting 50 megabits per second. But you can slow it down here to like 3G or 1 megabit per second to see what your app or your website looks like on a slow network connection. And that's actually really important because a lot of the world is still on slow network connections. Places like Facebook have 2G Tuesdays at Facebook, where they throttle everybody's Wi-Fi down to 2G so you can see what the apps look like and they get an idea of what their customers see on slower networks. We have the ability to decrypt HTTPS if you install a certificate, so run sort of a man in the middle, so we can see that we can analyze that traffic. And then we can also record the video on the screen while the trace is running, so you can see what was on the screen while you were testing, while the packets were coming in and out. Then you name it, and then you go. And so what happens, 2 clicks, was testing an application, and what you can see is up here in the upper left-hand corner, you can see the key, and that's the VPN. So a VPN is established right on the device, but it terminates on the device too. So the traffic just goes out over cellular or Wi-Fi. But because we have that VPN, we can collect all the traffic. We can run it sort of as a man in the middle there. So you're able to collect all the traffic, you can test your application, and then when you're done, this is on your computer screen, you hit stop, it stops the collection. It pulls it all over to your computer for analysis. And the first thing you see when you do the analysis is 40 best practices. And so the idea is, rather than getting it into Wireshark or another tool that looks at network and data packets, we give you green check marks and red X's. And green check marks are good and red X's are bad. And so that gives you the ability to drill into where there might be issues, find the red X's, figure out what files are having problems, and then you can go in and fix the problems that are happening in your mobile application. So we've tried to make it very straightforward and simple to find the problems so that you can fix the problems in your mobile application. Talk a little bit about web page test. It's a website, so you can just enter the URL you want to test, where you want the test to be run, what type of browser. I'm using a Motorola G4 using Chrome. And then you can set up the number of tests, how fast you want it to run, and you can run the test. And so these are synthetic tests run all over the world. These are being run in Virginia in the United States. And as you can see, there are a lot of different options. You can do scripting, you can do all sorts of great stuff to test your website if you want to. And so you get these sorts of results. And you get some grades up here at the top, you get all sorts of timing stuff, and you get a waterfall. So these are all of the objects that are loaded, and you get sort of an idea over time how quickly they loaded. And we'll talk a little bit more about this as we go through the presentation. But I'm going to talk a little bit about ways you can optimize content delivery. And so I'm going to start off with a little story. I live at the bottom arrow up there in Washington State. And I ordered a package from British Columbia, which is the top arrow right up there. And I ordered it, and I thought, I'm going to get that package really, really quickly because we're pretty close to one another, right? You know, a couple hundred miles, a couple hundred kilometers. But then FedEx decided to ship my package to Memphis, Tennessee first, and then shipped it way up over there. And so we actually see this in mobile applications where there are issues where the routing of the traffic is all sort of helter-skelter, and that actually causes delays in the mobile application. Facebook had an example where their customers in Indonesia were being served from a CDN in Brazil. And Indonesia and Brazil aren't really connected by any undersea cables. It was the traffic was traveling to North America and then to Tokyo and then back to, it was like halfway around the world. And so one of the reasons they were having such poor performance in Indonesia is they were serving the traffic from the wrong side of the earth. But we'll get some more examples of that. Let's see, it's not going to work now. There, okay, I'll click. So here's another example. Have you guys heard of cryptojacking? Yep. Okay. So I did a blog post on cryptojacking, and so CoinHive is one of the ones that is probably the most common one. And they only have one server where so cryptojacking is where it's JavaScript that runs on your website that's mining cryptocurrency on every single person who uses your website's computer. And so if you open up a page that's cryptojacked, your CPU goes up to 100%, the bottom of your laptop gets really, really warm because it's trying to mine cryptocurrency for somebody. And this company that does this, they have one server in Germany, and you can actually look to see how long it takes to ping that server. Right? If you're in Munich, it only takes 10 milliseconds, but in San Jose it's 150, and in Singapore it's 200 milliseconds. And so the further away you are from the content, the speed of light is really, really fast, but it can still take a long time. And so what you end up seeing is this traffic is coming all the way from there, and every time CoinHive is making an update, it's traveling, I don't know if that's exactly halfway around the world, but maybe a third of the way around the world. So a long distance. So if you have a website or a mobile app, a CDN is a great way to optimize your traffic. And so the idea of a CDN is all of your content is cached on the edge of the network. So the first time someone in Australia asks for your content, it's pulled from Romania or the United States, wherever your server is, but then it's stored in Sydney. So your second customer in Australia gets it in just tens of milliseconds as opposed to hundreds of milliseconds. And this is a company that obviously has CDNs all over the world, so that the content is stored on the edge of the network and you don't get those long latencies of the delivery taking a long time to arrive. So back to this graph that I showed you earlier. This is a test. I ran it in web page test of that application using the Moto G4, and you can see it takes 7 seconds for that page to load using my synthetic testing. And if you look, it could be, so that could be desktop and maybe this is mobile, or network speeds. It takes a little bit longer for these pages to load. But let's look at some of the other results for this web page. The first thing that happens when you go to this website is it does a redirect. It does a 301 redirect to the HTTPS version, right? So not secure, secure, first redirect, but it takes about 960 milliseconds for that to happen. The first content doesn't actually download until about 2.2 seconds. And so, unfortunately, whoops, I clicked twice. According to web page test, that gives this site an F for the time for first byte. The time to first byte, obviously the faster the first byte appears, the faster everything appears on the screen, and unfortunately it gets an F. However, this is not the only website that does that. You may have heard of these guys. And they have 2 redirects the first time you visit their website. And you can actually see that it can take, it takes up to 2 or 3 seconds before content appears on Google the first time you visit it. It's all cached, so the second time it's a lot faster. Let's see if the video works. It's not going to work. Because I'm on a different computer, I don't think the video's moved. But this was going to be a video. Another cool thing web page test does is it shows the video of the page loading. And so basically just imagine a white screen, 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 the page loads. It loads really fast once the content arrives, which is all right in this this time frame right there. But the first time you visit google.com, you can see there's a long delay before the content arrives. So let's talk a little bit about content delivery. And this happens to us all the time in America, where you order something and it's a tiny little box, but they send you a giant cardboard box and they fill the rest of it with air. And a lot of the content that's delivered to mobile apps and to websites is sort of like this. It's not being delivered super efficiently. And so we're just going to go through that a little bit. So this is a study of what sort of content is delivered to websites. And it's basically 25% text files, it's 50% images, and it's 25% video. So I'm going to kind of break my presentation up into those sort of 3 categories to talk about ways to optimize that type of traffic. And so this was an app that I tested. It's a video app. And this launched, so you start the app, you log in, and it populates this screen with 130 kilobytes of JSON. And so that JSON has important things like the name, what time it's on, and a link to the image that's going to load. And so all of that content needs to be downloaded before the second request can go off to load all the images that need to show up before you can use the application. Now the problem is, this JSON file was not compressed. And as you probably all know, things like gzip or Brotli are compression algorithms that will make those files a lot smaller. 16 kilobytes, 12 kilobytes, 88 to 91% smaller. Obviously, if it's that much smaller, it's going to download to the phone a lot faster, which means the requests for those images can be made faster, making this page load faster, which makes people not feel like they're jumping off a cliff, or whatever that analogy is back at the beginning of my talk. So by making that file smaller, you're not saving a lot of data, but you're speeding up the delivery of the content to this mobile application. So if we look at the HTTP archive, which is studying the top 1 million websites, and in the top 1 million websites, you can see these are different file sizes up to over 100 kilobytes. Most files use gzip, but there are a number of files, still 200,000 that don't use any compression at all. And then there's a small amount that are using broadly. But if you look at how long it takes those files to download, the not compressed image or the not compressed text file always takes longer to download. So just adding that compression is getting these files delivered faster to your customers. Faster obviously means a better experience for them. So now we can hop to images. Images are everywhere, right? Every single page has images, and there's a lot of things we can do to optimize images in websites and mobile applications. The first one is pretty straightforward. Exif Data, you guys know Exif Data in images. And so Photoshop is egregious about this. If you save things in Photoshop, sometimes it adds thumbnails in the metadata. And so the metadata actually has thumbnails and can actually have megabytes or hundreds of kilobytes of data that has nothing to do with the image, but bloats the size, so it takes longer for it to download. So this image is 30 kilobytes, but it had 5 kilobytes of text. If you cut out that text files, obviously you're saving 16%. It'll download that much faster. There are a lot of tools that will automatically remove the Exif metadata from your images when you put them up on your server. So I just encourage you to make sure that that's turned on inside your system as you're uploading images to your servers. This is another application. Well, it's the same application, but you can see all these movie posters. And I'm going to focus on this little tiny image here in the bottom left-hand corner. This is my phone, so it's 1440 by 2560. And then when that image was downloaded in the bottom left-hand corner, it was 1,555 by 1,200, which is a lot larger than it needs to be to show up in that bottom left-hand corner. And the image was 1.5 megabytes, right? So I mean, that's huge. And it's going to take a long time for that image to download on a restricted cellular connection. You can see I was using Wi-Fi. You can see up in the corner I was using Wi-Fi, but for some people that won't matter, but for other people that page may take a long time because I would imagine that all those other images are not properly sized as well. And so you could imagine that could be 8 or 9 megabytes of images just for that screen. So things that you can do. Well, you can see that the image is only half the screen. So what if I resize it so it's only 720 pixels wide? Half the screen. Now, the image is 368 kilobytes, so it's 70% smaller. Obviously, we made a huge savings there. I just did that manually in preview on my Mac, right? You just change the size, it saves it, and you get a new image. Another thing we can look at is the image quality. So it was a JPEG file, so you can reduce the amount of quality. It cuts out the pixels. JPEG is a lossy compression, and so when you remove the number of pixels, you start to get jagged edges. It may not look beautiful, but 85% quality is sort of one of those, it's not an industry standard, but usually it's good enough, and it'll save you some kilobytes. I think Google at one point was recommending just save it at 85% quality. No one will really ever notice. And it doesn't work for every image, but it works for a lot of images. It's sort of just a handy reference. And so if I save that at 85% quality, I can't really see a difference. And if I squeeze it down to that tiny little thing there, no one is really going to see a difference. But if I zoom into that's the difference at 85% quality. Right? So if I make it really big on a monitor this huge, you can see the difference. But for the average mobile user who's just looking on a tiny little screen there, they probably will never know the difference. And that gets us to 553 kilobytes, which is 64% savings. But now the cool thing is I can do both of them. I can do 85% quality and I can reduce the dimensions, and we're down to 178. So, I did all of this manually. And obviously, every single device is a different screen size, so it would be very hard to make a bazillion different sizes of the image. But there are tools out there, like Cloudinary. And so Cloudinary is a tool that you upload the images, and then you can just change these parameters in the URL. And it will resize the images for you automatically. So this is in 85% quality, width 720. And then I was playing with Cloudinary. I went a step further, and I clicked it twice. All right, we'll just do one. I changed it to auto scale, because remember that 85% is just kind of a guess, right? That usually gives you pretty good quality, but it may not always give you great quality. When I give it auto, it actually got smaller. It went from like 178 to 128 kilobytes. So we're at like almost 92% smaller. And then the last step I did is I let it change the format to WebP, because this is an Android phone. WebP is a new image format from Google. JPEG is from the 1980s. This is from the 2010s. It's a better algorithm. And we're down to 84 kilobytes. So we've now made this image almost 95% smaller with just a few things. And if you use a tool like Cloudinary, it can just be done. You can have it automatically. You could programmatically set the width so that it sends down the right width for your phone, or a width near the size of your phone, of the phone your customers are using. And as I was alluding to earlier, it's really hard to do this for all of the images. This is a tweet from the end of last year of all of the Android devices that hit Akamai for 24 hours. And I think he said, I don't remember how many there were, but there were like 6,000 devices. And so the big size is the Samsung S7, and then it gets, because there's just more of those devices, and as it gets smaller, there's just not as many devices. And then the idea with green is that it's a fast device, yellow and orange are slower, and then red are really slow devices. So what you can see is there are actually a number of devices that are actually relatively slow that have a lot of customers. And so you may want to, those are things that you need to think about when you are building your apps and your websites. So responsive images, I had a demo, but my computer doesn't talk to this screen, so I can't show it to you. But when you build a website, responsive images, you can set a maximum width, and then you can say, when the screen is 480 pixels, show an image that's 320 pixels wide. And then if the screen is a little wider, you can give it a bigger image, and then at a full-size screen, I'm giving it a 1024 pixel wide image. It's the same image uploaded once to Cloudinary, but it only downloads one of these on the browser web page, so that if you're on a small screen, it downloads a small image, but if you're on a big Retina laptop, it's going to download this big image. Customers all get a great experience, but the people on the smaller devices aren't being killed by the giant Retina image. So that's one thing that you can look at. So animated GIFs, this is my goat. And I think this is a video, so I think I can make it play if I can find the mouse. Maybe not. Anyway, so I took a video of my goat, and the video was 1.4 megabytes. And I turned it into a GIF, and now we can see the goat eating this cedar leaf. And I turned it into a GIF, and so a GIF obviously is now 256 colors, because that's the limit of the GIF thing, of the GIF palette, but it's also 3.8 megabytes. Animated GIFs are really, really big. So it actually got lower quality, but 270% larger. Let's see, did that do it? All right, and so why is that? And so the way a GIF works is it's like a flip book where you have a drawing and you flip through all the different images. There are actually 35 images of the goat that it just plays over and over and over again in rapid succession, whereas the video does better compression through time. And that's why video files have better compression than animated GIF files. So what I can do is if I make my MP4, I make it 256 colors so it looks GIF-like, right? So it kind of has that crappy, grainy look that animated GIFs have. And I turn it into a video, it's 250 kilobytes. So that's good. I made it a lot smaller by doing that. But the problem with this is if you use a video tag on your website, the video isn't preloaded initially. So everything else loads on the website before the MP4 is loaded on the web page. It's slowed down. But what you can do on mobile, if you use this video tag, it will play this video in a loop, and it's muted. So if you want to autoplay a video on mobile, it has to be autoplay on and muted so that you don't play loud videos while you're surfing the web in class or whatever. That's the rule for both Safari and Chrome today. So this will actually play that video and loop it like it was an animated GIF with many, with, what was it, like, what was the percentage smaller? 93% smaller, so it's going to load a lot faster. Now the problem is, of course, the video isn't preloaded. Now in Safari Preview, you can now put videos inside a picture tag. And so what you can do is you can say, I want to play this MP4, and it will actually play the MP4 inside the picture tag, and it's a lot faster because image tags are faster than video tags when the browser is loading the page.
In Safari? You said Safari.
In Safari, yes, in the preview. So it isn't actually out commercially yet. This is it as of December, so it's getting there. There's a blog post about it down here, so if you want to read more about it. This is great if you have a short picture of goats looping. But if you put a 5-hour movie in there, it's going to play that whole 5-hour movie automatically. So you have to, use the power that you have with this picture tag responsibly, so that you're not, obviously blowing up the web page. All right, and so now we're going to get to video, because video is also another important thing that's growing, and as apps and sites become more immersive, we're really going to see more and more video content coming down. And so this is a great quote that some company was talking about. Buffer rage is the state of uncontrollable fury that you get when it takes a long time for the video to start up or it stalls, because no one likes stalls. And then of course we all know that when you get mad, you throw your phone and then you crack your screen. Don't do that. All right, so let's talk a little bit about video startup delay. This is a paper from Akamai from a few years ago. And what they found is, you get about 2 seconds where people are willing to wait for a video to play. And after 2 seconds, you start every second afterwards, you lose almost 6% of your viewers. So if it takes 5 seconds for the video to load, you may lose about 15 to 18% of your viewers just because it took too long for it to load. So what can we do to make sure that video loads quickly? I'm going to talk through a little bit of that. Now this isn't one size fits all because there's different types of video on the internet. Right? You've got the cat wearing a shark on a Roomba chasing a duck sort of videos. Did that come to Romania? Did you guys all see the cat wearing it's a cat wearing a shark costume on a Roomba chasing a duck. It's on YouTube. I don't know. Right? But when it's something ridiculous like that, people give up a lot faster. That's the movie. People are willing, you're going to spend 2 hours watching a movie, you're going to wait a little longer. You'll be more likely to all right, I'm watching Star Wars, I'll wait 20 seconds for it to start. But seriously, there's a whole, I don't know. The internet's a strange place sometimes. All right. So what leads to startup delay? So when you're streaming a video, what happens is the first thing, and this is HLS streaming, which is the most common streaming use today. The first thing that happens is a manifest file is delivered to the device. And that lists all of the available streams that can be shown. The player chooses a stream. Then a stream manifest that gives you all the different segments. So the way streaming works is it sends 2 seconds of video in chunks, so it can play 2 seconds at a time. You don't have to wait for the entire movie to download, you just can watch 2 seconds at a time. To everybody watching the movie, it's seamless, but it allows the video to start up quickly. So the player starts downloading these segments into a buffer, and that's what this little line is. You see it in YouTube all the time, the little red line in front of where you're playing. That's how much video is downloaded. And so the idea is you want to make sure you have a lot there so that the video doesn't stall. And then once the player decides there's enough video in the buffer, it'll start playing your video. So what does a manifest file look like? This is a video, and you can see there's 2, 4, 6, 8 different streams that are available. And so what the player does, well, how does it pick which one to play first? It picks the first one. You have to do something. And in this case, the throughput of the first stream here is 8.5 megabits per second, which, as you might imagine, on a mobile connection might take a while to start up because it's going to be really high resolution video, and it's going to have a lot of data. So it may take a long time to get those first 2 or 3 or 5 seconds downloaded to begin playing. So what happens? And I'll show you what happened when I requested this video. The player says, all right, I want the 8.5 megabit per second stream. It starts downloading it. The player is like, oh my goodness, it's going to take forever. And the video doesn't play. So the player says, all right, we need to get a lower quality video to get this movie started so that we don't lose our customers. And it drops down to 600 kilobits per second, which, I'll just go back up here. It dropped down to this one. So, the third lowest video quality. All right, now I'm clicking way too much. And so you can see it downloads the manifest. It tries to start downloading this high quality 1080p video. And the player quickly says, this is going to take forever. Drops to a lower quality version. Begins downloading. Here's segment 0, 1, 2, 3. And then I was on fast Wi-Fi, so the player's like, oh, you know what? Maybe we can handle it. And starts downloading 3, 4, 5 at that really high quality video. But we had this delay here before we could get any of the video playing. And so what can we do to avoid that? So generally what a lot of providers do is they pick a middle of the road throughput. 1.2 megabits per second is usually pretty good. It's sort of a balance of the quality. It's the middle of the road quality, but it's going to download really fast, so the video will start playing quickly. So you're balancing the startup delay with the quality of the video. So that's one thing you can handle. You can reduce your startup delay by just picking a bandwidth. So what can you do to reduce stalls? So this is a video that I was watching, and you can see here that as long as the video is downloading faster than it's playing, you're not going to have a stall. So you can see as we walk 1, 2, 3, 4, this video is going to play all the way through without stalling. It's downloaded all 38 seconds of a cat on a Roomba wearing a shark costume chasing a duck. So it's not going to stall. But what does lead to stalls? So you have a little bit of buffer right here, but the video is playing faster than it can download. You can see we're running out of buffer right here. And then eventually the video stalls. So this video stopped playing right here. And it doesn't actually start up again until the buffer fills up an appropriate amount for it to start playing again. So the buffer is filling, but the video actually, it looks like it should be able to play, but it doesn't. I mean, if you go press pause, play, maybe you can just jump start it to start playing. Sometimes that works. I do that. You guys do that, like when a video stalls, right? Yeah. All right. And so the player is trying to balance how much it can download versus how quickly it's playing back. And so it's using those available streams to balance that. So it may, if the network gets faster, it may go to a higher quality, or if the throughput gets lower, it may go to a lower quality video, just to make sure that this buffer is filling up so that the video doesn't stall. And so if we look back at this list, I'm going to show these 8 streams in a different view. Cloudinary has a tool that allows you to upload one video, and it will create all of these different bandwidths for you, so you don't have to, encode 8 different streams. They've picked streams that work really, really well and let you upload, and you can serve them from their servers. But let's look at these 8 streams. And what we can see here is that we've got all these nice, these are the ones that run on a low quality network. These are the ones on a faster network. But we've kind of got this big jump right here in the middle. And we have large jumps in video quality that can lead to problems where the player can't find that sweet spot to play the video. And that's actually what happens when I stream this video on cellular. And so what happens is we start again at 8.5 megabits per second, and the player quickly says, no, can't do that. And it drops down to 600. And it downloads segment 1, 2, and 3. But then it's like, we've got a little bit more throughput. We can come up to 3.5 megabits per second, and it downloads a few more segments. But that was actually a little bit too much. So now it's running out of buffer. It's playing back faster than it can download content. So it drops back down to 1200. But if we look, we've already downloaded this segment. So this 2 seconds of video, we've downloaded it at high quality. Now we're downloading it in low quality. Well, why would you download it in lower quality if you already have it at a high quality? That just wasted, that file worth of data. And you can see it starts jumping back and forth, right? It just keeps going back and forth because the sweet spot is somewhere right in the middle there, and it's the player's trying to find it, but it can't. It keeps jumping between 540 and 1200. And unfortunately, what this can do is your customers may see the quality get good, and then get bad, and then get good, and then get bad. And to me, that's kind of annoying too. Like if it happens once and it kind of gets pixely and then it gets better, that's great. But if it happens that way through an entire movie, you'd be really, really annoyed. At least I would be.
And you break your screen.
And then you break your screen. Yes, exactly. So, in summary, we've gotten to the end. I thank you all for hanging in with me. We're looking at delivery speed, so you can use CDNs to host your content around the world to reduce the amount of distance that the packets have to travel. You can reduce the number of redirects, so how many times it goes to different servers to see things. I had a music application that every single time it downloaded the album art, it was doing a redirect. So there were actually 700 redirects in under 5 minutes of testing. So it was like doubling the number of connections. It was adding so much latency to the application. And it was getting a lot of press at the time in America. And my coworkers were like, hey Doug, have you looked at this app? It's really, really slow. And I knew why, because it was doing all these redirects inside the application. So then we get to content delivery. You can compress text images. You can compress text. You can also compress images by affecting the sizing, the quality, and the format. And then you can do a lot of things with video bitrate to make the video stream faster and not stall. And so in summary, I've got a bunch of the tools here with all of the different URLs that you can access them. Web page tests and website speed tests for web and mobile web. Video Optimizer is the tool at AT&T that I've worked with for many, many years. I wrote a book called High Performance Android Apps. That's a link to the PDF. If you're interested, feel free to take a look at it. And then if you want to talk about images, Cloudinary has some really cool stuff on how to optimize images and also video. And then thought this would be kind of cool if you guys want to take your website or your mobile app and profile it, and then look to see if there's a way to optimize it. You could test it before and after and send me those results. When I was showing those Cloudinary slides to people at Cloudinary, just to make sure I did it right, they offered to give away a prize. So if you guys want to test your website or your app before and after and show an improvement, you can submit the results to that web form and we'll win a prize courtesy of Cloudinary. So if you're interested in that, I encourage you to submit. And if you have questions, you can hit me up on Twitter. I'm Doug Sillers, or you can email me at highperformanceandroid@gmail.com. And with that, thank you very much, everybody, for listening and being so attentive. I appreciate it.
Thank you.
And if you have any questions, I'd be happy to take any questions.
Have you ever worked with any of the apps or portal